Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right. So this is a project that we've been doing in Microsoft Research Networking Group for the last 6 to 8 months or so. I'm Jitu. This is a joint work with my colleagues. Ranveer, he is here. Alec isn't here. Brian isn't here. And Victor is here. And a bunch of interns also worked on this last summer. Okay, so I think the introduction slide is sort of now moot. It's been all discussed before. Wireless networks are hard to manage. Lots of money is spent on wireless networks, and still people complain. There's this perception that wireless networks are flaky, they're less secure, and there are several different problems. Users complain about the fact that there is not adequate coverage. They complain about authentication problems, performance. Network administrators worry about providing appropriate security. And as we discussed in the isolation group, wireless networks are much easier to attack and much more difficult to isolate compared to the wired networks. So you need better wireless management systems, and maybe they'll go a little bit further towards making the wireless network less flaky, more secure. Okay, so how do you build a wireless management system? So any management system for network has three parts. You gather the data, you analyze the data, and then you take some action. In each of these cases, the wireless network presents its own challenges. So first of all, the clients in wireless network are mostly mobile, and by mobile, I don't necessarily mean that most people are using VoIP phones and are walking down the hallway. I mean that the client is here one time, after a while the client is in some other place. And the problem itself that you're facing with the network could be location specific. So it's rarely the case that you say, my laptop doesn't ever get good wireless connectivity. Usually are problems like, well, my laptop when I'm in my office works fine, but when I go down to this particular conference room, never gets good connectivity. Okay. So basically what you need is you need an integrated location service for wireless network. Any wireless management system you build, it has to be able to associate a location with whatever problem that you're seeing, perhaps even pinpoint the location of the problem, location of the client that is reporting the problem. Add to this the fact that the signal propagation indoor is very complex, and there are many channels that you need to monitor, especially if you're monitoring security. You have to monitor them all of them simultaneously to prevent an attacker from sneaking past you. The asymmetric link problem was discussed earlier. What you see at the client in terms of how good the link looks could be completely different from what the AP perceives the link to be. Okay. What that means is that you have to deploy multiple monitors to gather the data, and these have to be deployed in a very dense manner because you need multiple vantage points and gather data from all of them. What follows from this is that any management system you deploy based on multiple vantage points better be scalable and self-configuring. Otherwise, you'll spend more time managing the management system than managing the network that it is supposed to manage, and you don't want to do that. And no matter how many sensors you deploy, you're always going to get incomplete data. And this is not necessarily a problem that's specific to wireless networks. Even with wired networks, you're never going to get up-to-date data. Parts will be missing. Whatever analysis engine you build has to be able to cope with incomplete data. Okay. So what is the state of the art? You can classify these into sort of three different categories. Most of the current solutions, including the one that Microsoft uses, use access point-based monitoring. And these are either single radio or dual radio access points, and they provide monitoring in addition to whatever services they provide as an access point. And the advantage here is that such solutions are very easy to deploy. Access points are usually under central control, so you can easily replace them with something else if you want. The downsides, however, is that there are usually few access points in a corporate environment. And if you're talking about single radio access points, then that single radio must first serve whatever clients that are associated, can't go wandering off on other channels and scan those and try to report problems on those channels. So limited, you can use multi-radio access points. These are the kind of access points Microsoft uses. These are built by Aruba. But even then, the coverage they provide is somewhat limited. And most important factor is if you're trying to detect problems with how you have placed access points, for example, by definition, you can't detect that using an access point-based system. You have to get observations from a third party, from mobile clients or from somebody else. Okay. Specialized sensor boxes, these are the kind of things that the people at UCSD have built, or even fancier things that you can buy which do very detailed signal level analysis. Usually these are too expensive to deploy in a very dense fashion. And then you can also talk about monitoring by mobile clients, and there has been previous work in our group on this. But the problem with mobile, and the advantage of monitoring using mobile clients is this is excellent for unmanaged environments. When there is no system administrator, like for example here, it would be great. On the other hand, mobile clients cannot provide dense coverage. And the second thing is they're mobile, which means whatever history they report, problem they report, you cannot pinpoint its location. Battery power is a problem. A client might not want to spend its limited battery power monitoring for the good of the network. And obviously, if they're using their wireless radio to connect, they're not going to wander off on other channels and monitor them, again, for the good of the network. So our solution is based on two observations. So desktop PCs with good wired connectivity are quite ubiquitous in enterprises. And this, as many people have pointed out, will change as we go further along. We have thought about that too. That's sort of a separate topic for discussion. But the current state of the affairs is that most organizations have tons of desktop PCs with good wired connectivity. And outfitting them with a wireless device is pretty cheap. Plug in the USB dongle, costs $7 if you buy them in bulk now. Some of the PC motherboards are shipping with 802.11 built in. So you put these two together, and you basically get a dense array of sensors that can report observations back. And this is our platform on top of which we are going to build our monitoring system or a wireless management system. Okay. And the key characteristic, we get high sensor density at low cost. And that allows us to do effective monitoring of multiple channels in complex indoor environments. You might not hear signals from one office into another, but on the other hand, if you have a desktop in every office that's acting as a sensor, that's fine. Also allows us to tolerate failures. If you have deployed specialized sensor boxes, 2 of them fail, that's it. Part of the building is unmonitored. But now if you have very high sensor density, somebody takes their desktop online, that's fine. Okay. And it's cheap because it's leveraging existing desktop resources. We are sort of sneaking off unused CPU cycles, unused network bandwidth, and we are feeding off of that. Okay. Second point is desktops are mostly stationary. People don't generally wander off with their desktops, and that allows us to get more predictable coverage. Also allows us to do meaningful historical analysis. So if a particular office can see was seeing an access point with some signal strength for 3 months in a row, suddenly it stops seeing it in one day, it means something. There is some potential problem there. You cannot do this if you are doing monitoring using mobile clients. And since the desktops are stationary, they provide sort of good waypoints based on which we can build a location system, which we have done, and that's an important component of any wireless management system. Okay, and our system, the way we have built it, it's completely self-configuring. You just have to go plug in the desktop, run a little piece of software, and it starts acting as a wireless monitor, feeds the data back to a central database, and an analysis engine works. So here is the basic architecture. We use these little Netgear dongles, USB dongles from Netgear. Plug them into desktops. They become what we call air monitors. They feed the data into a central database. The database also gets data from other sources, SNMP, some configuration data, building maps for better location. We also have some machines that we call land monitors, which get data from wired networks. We mostly only deal with simple broadcast packets at this point to correlate DHCP requests that we see on wireless and compare them with how they're behaving in wired networks. Not doing any fancy correlation analysis yet. And then the data is all processed by a central inference engine. The idea here is that, since we are mooching off of people's desktop resources, we don't want to do too much complicated analysis on the air monitors themselves. We want to do a little bit of analysis there, enough so that we are not sending a whole bunch of data over the wired network and overwhelming the wired network or overwhelming our database, and yet, leave all the complicated analysis to the inference engine here so that we are not eating up too much CPU power. And this is, yeah, sure.
Is that a real problem right now in terms of the volume of data that you have?
Yes. If we started shipping off every packet, remember we have a very dense deployment of monitors. So every packet you see on the wireless is heard by multiple air monitors. If you start replicating that packet on the wired network, we will have problems. Here is a basic monitor architecture. Somebody was asking this earlier. It's all written in C#, so all it will do is if we have a bug, this process will crash. Nothing bad will happen. So we have a custom wireless driver that feeds data into what we call a filter processor. Filter processor's job is to take the data and construct summaries over 30 seconds, 1 minute, whatever time interval the user has defined. And then these summaries are shipped off to the database. And the way we have structured this Air Monitor. It runs as a Windows service. If you want to deploy a new application, all you have to do is to write a new filter. So, for example, detecting a denial of service attack means you're looking for certain kinds of packets over certain time periods. Okay, and that's your summary that you're constructing, and your inference engine can do the rest of the job. And we have made the process of writing filters really easy because we have a bunch of support modules. We have a parser, we have a DHCP parser, we have something that lets you deal with the database in a very transparent manner. So basically, it's very easy to quickly write a new filter and enable a new application of the DAIR system.
Okay. Well, it's probably too early to ask this question, but I will anyway. Is whether you thought about just creating, building a little bit around that thing and making it essentially embedded so that it just uses the power instead of actually uses the CPU and everything else. I mean, so you're reaching off.
So we have.
To me, that an embedded little processor actually with this thing on it
yeah.
would be.
So we have. We have thought about this. In fact, one of the things that we were just discussing a couple of days ago is, there are these nice new, there was a camera that was profiled in the Wall Street Journal a couple of days ago. And the great thing about it is, you take whatever, little videos, pictures you want to take, it has a little USB port, you plug it into your machine, and autoconfig autoexec.run whatever it runs. So basically it appears as a disk to the system, and automatically a program starts. Video editor, everything is on the camera. You don't need any special software on your PC at all. You can take it, plug it into any PC, and run it off of that. Think about this. We could take this entire monitor, a little flash memory on the USB dongle. You go plug it in, you're all set. So you're not basically doing anything. You're right. That we would like to do that.
So it's a little different than what I was thinking. I was actually thinking that you actually have a system on that thing too. You can get the little embedded systems, and essentially they'll run off USB also, and you sort of daisy chain this thing, and then you actually could have telemetry, smarts in that thing, and it could do what it needed to do and push information back across wireless. It wouldn't actually have to use any resources if it was connected or not. In those circumstances, you could plug it into anything that had USB and had power. You're reaching power, but so anyway, so it's just a mix of other things,
No, this is good. Okay, so we have built a bunch of applications. Thanks. We have built a bunch of applications using this architecture. So the ones in blue are already running and sort of operational in some definition of operational, I guess. The blacks that we are attempting to build this summer and going forward. So basically, the initial the desire was to build security applications. Detecting rogue access points, detecting denial of service attacks, pinpointing where they are coming from, and most of the time you can inform NetOps. But if you have this great army of sensors lying around, you can attack the rogue access points if you're really sure that it is rogue, right? You can launch a denial of service attack against a rogue access point. We've also built applications that let you monitor RF coverage, see if a client is getting poor RF coverage. And here the point is that we don't require any cooperation from the client to either locate it or figure out that it is getting poor performance. Okay, and eventually you can think about it like this. These sensors, they don't have to essentially act only as monitors or sniffers. If they detect a problem, if they detect overload, they can take over, they can act as access points themselves, and there are clearly some security issues here in terms of who is allowed to connect and what they can do. But nonetheless, it's possible that they can take over as access points and provide access point services. Ultimately, you could get rid of access points, and this could become the wireless infrastructure that is essentially provided by your department or your office or your corporation, right? And the key substrate supporting all of this is essentially the location service that we have built that lets us tell, that allows us to tell where the problem is occurring, for example. And the key, and I'm not going to go into the details of how the system works. There are many wireless location systems that keep,
So I'm a little confused about the whole situation because, the desktops aren't moving, and oftentimes they may be under desks too. So, exactly how there are a lot of holes that may exist that you wouldn't actually notice or see. The library for my library, my library may not have any desktops.
Yeah. So if you have large areas where there are no desktops, then you will have to deploy a few specialized sensors. Absolutely. Yeah. But most areas will be covered by desktops, at least in a place like Microsoft, for example. Okay. Most CS departments also, I imagine, for example. Yeah.
Areas that are holes, you can obviously put on access points there. So you use your system kind of interoperate with access points to kind of holes.
not what we have built now, but obviously that's a great thing to do. I mean, whatever data we get from access points, we are happy to take it. Right now, we take some little bit of SNMP data and where they are located and things like that. But any other thing that we can get from access points, obviously, we're going to use it. So we built a location system. Basically, our location system is completely self-configuring, and it can locate uncooperative transmitters. We don't need any cooperation from the clients. And it provides, on the flip side, it provides only office level granularity at this point. We are not terribly interested in figuring out, oh, that client is in that corner of that conference room. It's okay to say, the rogue access point, the denial of service attack is coming from this particular conference room. We are generally happy with that. And how it works is the air monitors locate themselves. We have a bunch of heuristics there, essentially. We figure out which office is this person located in, and so on and so forth. And then they basically regularly ping each other at various, they send out broadcast packets at various power levels or at various frequencies. And they essentially build a radio propagation map of the environment in a completely sort of automatic fashion. This is the step that most wireless location systems previously were doing manually, which we now don't have to do because we have such a dense deployment of sensors. Okay, and then we can basically, fit a very simple model to it. And we have found that actually, since we have so many sensors that are listening, a very simple model does get us almost all the way to the office level accuracy. Yeah.
So do you do channel sweeps as well?
Yeah. So here is just an example application, detecting a rogue access point. I'm not saying that this is the main application of the system or anything. It's just that it demonstrates all the aspects of how things work. So the main problem is that a careless employee brings an access point from home, plugs it into the wall. You now punched a hole into your network. Okay. And, anybody is free to connect. 802.1x is useless at that point. Simple solution is you build a database of all SSIDs and BSSIDs, raise an alarm anytime you see one. That, of course, has this problem of false positives, which is that it could be the Starbucks outside. Whose beacon just somebody happens to have overheard. So what you really want to know is whether this access point is connected to the wired network that you have. And we have a bunch of tests that take advantage of the density and the lot of air monitors that we have. Can't go into the details right now, but for example, one of the simplest things you can do is you can turn one of these air monitors into a client, try to connect to that access point, and try to ping a host on your corporate network that's accessible only from inside. If that ping succeeds, you know that the access point is plugged into the wireless, into the wired network. Okay. There are a bunch of other things we can do because this mostly will fail. Any access point you buy off the shelf, even in Radio Shack, has web implemented, right? But there are a bunch of, I'm happy to talk offline.
So this morning you made a comment, I guess, made a comment that network access protection was not that big a deal in the universities because you were looking at the egress traffic, right? You were just you didn't care about somebody coming into the university, but really cared about going out of the university in the internet. In corporations, it's actually very important not to even let anybody in. And so problems like this, which is maybe not a concern, become very, very important to solve in corporate America, right? Because they don't want malicious or non-malicious people who plug something in and punch a hole in it.
I would characterize this particular strategy as a behavioral strategy, not a integration strategy, right? You're trying to figure out what's actually going on, and then once it's going on, it's all about the latency.
Yeah, that's right. I was just commenting on the earlier.
Yeah.
There's also the question of insight. The assumption of the model that you described is that you have to make order primitive has some semantics that are important. And increasingly, that's not even true in industry.
Well, we know we do have a semantic here, and it is important. We do care whether somebody plugged in an access point in our wired network. We don't care if somebody just plugged in an access point in the wall and it's just broadcasting beacons. You can connect to it and go nowhere, then nobody cares. The question is whether it's plugged into your wired network and has punched a hole in. So there is a perimeter.
Well, but the point is that they may have punched a hole just for them, right?
And you're letting other people in, for example.
It's where the perimeter defense is. If they punch the hole inside of that, you have a concern.
Correct.
But if your design philosophy is that perimeter defense is closer to the edge, then you don't care about that.
Sure.
I'm not sure what that meant.
Well, so for example, you're probably thinking IPsec. If IPsec is implemented, then rogue AP is not a problem. Is that what you're saying?
What do you mean by closer to the edge? I'm not sure.
If somebody punches a hole in my perimeter defense, that means the protection perimeter is outside where they were. The protection perimeter is not outside where they were, so it's not an issue. So, for example, if the servers protect themselves and do the access control after that, the fact that there's somebody else plugging in is not a risk to the data.
It's not. The question is yes. If you have deployed a server, for example, IPsec is one way to do it, right? You do end-to-end authentication. The server is protected from unauthorized access. Well, there are almost all the quote-unquote devices on the network don't have IPsec. Printers don't have IPsec. Your routers don't have IPsec implemented. I don't know. Maybe Cisco has it now, but most of the switches don't have IPsec implemented. They all have telnet ports to which you can connect and configure them. I'm not saying they're completely insecure, but they don't implement IPsec, right? So. No. This is just an example. I was simply saying that perimeter defense. I'm saying that perimeter defense is important because not all devices are powerful enough to implement a perimeter around themselves. Maybe we are going off topic here. This is not actually. This is a completely side discussion. Yeah.
Some people care a lot about rogue APs
yeah.
on network.
Yeah. But rogue AP is not the pointer there. This is a wireless network management system. Security just happens to be one of the apps that we cover. You still have to deal with things like denial of service attacks that we were discussing earlier in the session, and so. Okay. And anyway, so with current deployment, we have test beds. 40 nodes. It's an operational system. We have been running it for about well over 6 months now, so. The key characteristics here are system scalability. The load of the database server, we have pretty, junky database server, something that we just literally, one of the leftover machines. It's under 75% for 40 air monitors. And we have covered about 2/3 of a floor. I'll show you a map in a minute. The additional load on the desktops is, 2 to 3%, which is what you want. We're using mooching off other people's CPUs. And the wired network traffic is under 5, additional per node wired network traffic is under 5 kilobits per second. So that part of scalability is also sort of taken care of. Okay. So this is what our GUI looks like. I'm happy to talk to anybody who wants to talk more. This is our current deployment. Sure.
It sounds like a very good idea, but I was wondering, given that you have all of these monitoring points, each of these also is potential security vulnerability point for the monitoring infrastructure itself. Say a board intern or somebody who just gets a virus in that modifies some of your filters and content. So
a couple of different answers on that. So if you have the ability to modify the software on the machine to the extent that you can modify device drivers and filters, you can do far more damage, wireless or no wireless. So it's not like we are introducing any additional problem here. We are not even providing force multiplication, because if an intern could actually do this, then they could also go off and they could damage your Ethernet. What's the big deal, right? They could use Ethernet to attack your wireless access points. So that's one answer. Second concern is that since you have these wireless sniffers deployed, can somebody connect through them to your desktop and create problems? And the answer to that is no, because we have the driver won't let you connect. The driver has been modified. Now, of course, can somebody modify the driver and let other people in? Yeah, but I mean, you have such an insider job that they can modify drivers on the device. They can do so much more damage at that point that this is really not any additional problem.
So you said there was a coverage goal thing. I don't remember from the slide what you said. There was also interference application.
Yeah, so we can detect where there are, if people in a particular region are getting poor performance, we can try to figure out why they're getting poor performance and things like that.
An application already that does some of that in terms of coverage and capacity kind of analysis.
Yeah.
Okay. Any more questions? Great.